हर्षा, आप कल नहीं आए थे जेई की क्लास में? यस हर्षा।
No, sir, I
मैथ्स?
wasn't there.
व्हाई? सॉरी।
So, like, for J, I joined some other platform.
Yeah, I think we should start now. It's 37. So write the topic, chemical properties of chemical properties of alcohol. We are going to look at the breaking of two different bonds in alcohol. Okay, so first is RCH2, O and H. So if this bond breaks in alcohol, then it will show certain type of reactions. Similarly, if this bond breaks, then it is going to show some certain other type of reactions. So we can say that this is the breaking of CO bond. We will see some reaction in which the CO bond breaks. Breaking of CO bond. And if I talk about this, then it will be known as breaking of OH bond. So in both the cases, the alcohol is going to show you different properties also. For example, if I talk about this bond breaking, that is breaking of OH bond. So when the OH bond will break, obviously the electron will shift to oxygen atom. When the electron will shift to oxygen atom, then what is going to happen? Oxygen will have a negative charge, and this is the remaining part of alcohol that we are having, and that is why this alcohol is going to show the nucleophilic properties, because the electron density is at O negative. When the red bond breaks, then also the oxygen is only going to get the negative charge. The electron will transfer to oxygen atom. So now this fragment which is left of alcohol, it is going to show electrophilic properties, because positive charge यहाँ पे आ जाएगा कार्बन के ऊपर. ठीक है. So depending on which bond breaks, alcohol can show both the properties. It can act as a nucleophile as well as an electrophile. First of all, we are going to look at a few reactions that involves the breaking of OH bond. We'll talk that part in the A section. We'll call this reactions involving cleavage of OH bond. Now, in this, the first reaction is reactions with active metal. Reactions with active metal, they are going to involve reactions with those who have done electrochemistry. In electrochemistry, we have, or if you remember the 10th standard reactivity series, all the elements above hydrogen, they are going to show what they are going to show reactions with alcohol, and they are going to give you H2. So please write the first reaction is with, generally speaking, alcohols, they will react with metal. They will form metal alkoxide, which will look something like this, OR, and hydrogen gas will be liberated. H2 gas will be liberated. You can balance this out, but this is the general reaction that is going to happen. Metal alkoxide plus hydrogen gas. Okay, so alcohol on reaction with metal, it gives hydrogen. So for example, if I have CH3OH and we have a metal sodium, it is going to give you sodium methoxide, NaOCH3 plus H2 gas. Similarly, if I have methanol plus magnesium, because the valency of magnesium is 2, we will have Mg, and the methoxide will be 2 methoxide, CH3 whole twice, to balance out the charge on magnesium ion. And here also we're going to get H2. Similarly, if I have CH3OH plus aluminium, then it is going to give you aluminium. Again, methoxide, we are only going to call this, but it is going to have OCH3 whole thrice because the valency of aluminium is +3, and we will get again H2, hydrogen gas. So you can write a statement here: alcohols are weak acids and hence they react with active metals such as sodium, magnesium, aluminium, etc. to liberate H2 gas and form metal alkoxide. जैसे सोडियम के साथ रिएक्ट कर रहा है, सेम रिएक्शन कैन बी शोन बाय पोटेशियम आल्सो, मैग्नीशियम की तरह कैल्शियम के साथ भी, ठीक है. So this is one reaction which shows the acidic nature of alcohols. Anyone still writing? Rishita, Harsha, Zaina, anyone? No one is writing. Okay. Next, we are going to study, that is more important, the acidic strength of alcohol. Write the heading. Acidic strength of alcohol. Now, in acidic strength of alcohol, this is also very important. Why? Because you will get directly questions from here. That's one reason. Another reason is that one of the most important topic in the acidic strength topic, not of alcohol, but in general organic chemistry, is the acidic strength of carboxylic acid. So the concept that you are going to learn here will be applied in a similar way for the carboxylic acids also. So यहाँ पे सबसे पहले आप लिखिएगा what happens, what type of reaction happens when alcohol it behaves as an acid. We can write here RCH2OH. ठीक है, it breaks into RCH2O negative plus H positive. Now each and every alcohol is going to show similar reaction, and it is always going to give us H plus ion. It's always going to give us H plus ion. The thing that will be changing always is this alkoxide ion. And if you remember the names like this is the acid, and this will be known as its conjugate base. Conjugate base. You remember conjugate base, all of you, Rishita, Harsha, and Zaina?
Yes, sir.
Yes, sir.
Yes. In the 11th standard we studied, if you remove hydrogen from an acid, we form a conjugate base. The acidic strength will be directly proportional to stability of conjugate base. Okay. So if the conjugate base is stable, see, H plus ki stability, it is not going to matter, stability of H plus. Why? Because all the acids are going to give you H plus. What is going to be different in the different acid? The conjugate base is going to be different. Okay, fine. Another thing that is very important is the polarity of which one. Generally, all the answers you will get is from conjugate base, but another reason is what the polarity of which one. Please see here. If the oxygen atom and the hydrogen atom, they are having highly delta positive and delta negative charge. Okay. I'm representing things here in numbers, but try to understand high positive and high negative charge. For example, in a case I have, let us suppose, -2/3 charge on oxygen atom and +2/3 charge on hydrogen atom. This is one case. In another case, I'm having -1/3 charge on oxygen atom and I'm having +1/3 charge on hydrogen atom. Okay. Now the red case and the blue case, I'm going to talk in those terms. If I talk about the red case and then the products, so we have to go from -2/3 to -3/3. Because here we are having complete negative charge. -3/3 will be equal to 1, -1 charge. So if the polarity is very high, it is very easy to go from -2/3 to -3/3, or rather -1 charge, rather than going from -1 to 3/3. So if I have a high polarity, that means there is already a high delta positive and a high delta negative charges on hydrogen and oxygen respectively, then in that case, it will be easier for the hydrogen atom to get complete positive charge, and it will be easier for the oxygen atom to get complete negative charge. So if the polarity of OH bond is high, that means we can say the acidic strength will also be high. We can easily break that bond. So we'll write polarity of OH bond. If the polarity of OH bond is high, that bond can be easily broken into positive and negatives. So here, when we are going to talk about the acidic strength of alcohol, we are going to talk about different contestants also. For example, first of all, we will look at alcohol versus water. Then we are going to look at 1 degree, 2 degree versus 3 degree. Take it slowly. So I hope you have written this down. Number 1, you will write. We are going to discuss alcohol versus water. First thing, we'll look at ROH. It will break into RO negative, RO negative plus H positive. Secondly, we have water, which is HOH. This will break into HO negative, that is hydroxide ion, plus H plus ion. When I compare the stability of alkoxide ion and the hydroxide ion, in that case, I have to look at the effect of R. Here we have hydrogen, here we have R. So R is going to be what? R is plus I effect, right? R, it shows plus I effect, so it is going to give electron density. When the R gives electron density, the negative charge increases. And as the negative charge increases, stability decreases. So alkoxide ion is less stable than the hydroxide ion. So first thing we can write is that the alkoxide ion, RO negative, is unstable due to plus I group. Which one? Alkyl group. That is one reason. That is one of the main reason. That is main reason. Okay. Another reason is, please ध्यान से देखिएगा जरा. The oxygen atom is electronegative. It has tendency to pull electron density. Now alkyl group is plus I. It has tendency to give electron density. So oxygen already has a contestant who is willing to give electron density. है ना? Alkyl group, it is willing to give electron density. So what will happen? The oxygen will take electron density from the alkyl group, and it will not take much electron density from the hydrogen atom, because oxygen is electronegative. It wants to pull electron, and already too much electron is given by alkyl group. So this oxygen atom will be having almost all the negative charges from the alkyl group, not from the hydrogen atom. That is why this oxygen and hydrogen atom. Scroll up.
Yeah, because I didn't
What later?
know. Yeah, yes, sir. Done.
Done. Yeah, so I was saying that the alcohol, it has alkyl group, which is already satisfying the needs of oxygen as an electronegative element, and it is giving electron density. That is why oxygen does not have to pull too much electron density from hydrogen atom, and hence this bond in alcohol will be less polar than that of OH bond. Okay, because oxygen here, it does not have any charge, it has to pull electron density from the hydrogen itself. That is why this OH bond in water, it is going to be what? More polar. तो यहाँ पे आप लिखिएगा नेक्स्ट पॉइंट R OH bond, or rather write like this: OH bond in alcohol is less. OH bond in alcohol is less polar due to plus I effect of alkyl group. So from the above two reasons, we can say that therefore alcohol is less acidic than water. And that is one of the reasons the alcohol does not show this type of reaction. If you react this with any hydroxide based bases, for example, we have alcohol, ROH, and I am having NaOH. So NaOH is a good base. Okay, NaOH is a good base, so it should show some reactions like this. कैसा reaction show करना चाहिए इसको? That we have R2Na. Rather, I should write like this: sodium alkoxide NaOR, है ना? Sodium alkoxide plus hydrogen from the, this is acid, ये hydrogen देगा और OH base के साथ H2O. ठीक है, but ये हो नहीं पाता. This reaction does not take place. Why? Because if you look at the acidic strength, this is acid. ठीक है, and यहाँ पे कौन एसिड का काम कर सकता है? This is going to act as acid. ठीक है, so water की acidic strength ज्यादा होती है in comparison to ROH. That is why ये उल्टा reaction हो जाता है, and it is there in considerable manner. ठीक है, so write a point here. Alcohol does not react with metal hydroxides. Why? Because alcohol is less acidic than water. EU corollary said. Done, everyone? All if you done writing, is please tell me.
Yes, sir.
Yeah. Anyone still writing? Second, जो हम लोग को discuss करना है, this is going to be much easier for you guys. We have to discuss the primary alcohol versus secondary alcohol versus tertiary alcohols. Now, we have just seen that the acidic strength of alcohol, acidic strength of alcohol, it is inversely proportional to the plus I group. Just now we have seen that because of the plus I group, the acidic strength was lower. Therefore, we can say that 1 degree will be most acidic because 1 degree is going to have the least number of plus I groups, less number of alkyl groups, followed by 2 degree, and then followed by 3 degree alcohols. Okay. So why is this particular order? This order is due to more, please write with me, due to more plus I groups in 3D alcohol. Lastly, we need to discuss regarding alcohol versus phenol. Alcohol versus phenol. Zaina, Rishita and Harsha, ये समझ में आया ना सबको? Yes or no, please tell me, guys.
Yes, sir.
Okay.
Yes, sir.
Anyone still writing? No one is writing. So alcohol versus phenol. So here also we have to again see the same things. Alcohol is still less acidic than what we have seen. That what is the factor that also we have seen. Now, यहाँ पे please देखिएगा आप लोग. We have R CH2OH. ठीक है? It is going to give you. Don't write now, है ना? इसको आराम से देख लीजिए जरा. ठीक है? Listen. And after I have explained this, then you can write. This will get converted to R CH2O negative plus H positive. Now we already know this, that it is unstable because of plus I group. Now what happens with phenol, that we have to see. So phenol is something like this. We'll have benzene ring, which is having OH connected to it. Now it will break into phenoxide ion. We have double bond, double bond, double bond, and we have here O negative. Plus we are obviously going to get H positive. ठीक है, फर्स्ट थिंग तो यहाँ पे जो हम लोगों ने पहले डिस्कस किया है that this particular alkoxide ion, it is unstable due to plus I group. This is unstable due to plus I group. And we can talk about the phenol, that it is going to be stable because of the resonance in the phenol. This negative charge will come here and this pi bond will move here. So there will be a delocalization of the charges. And due to delocalization of charges, the stability of phenoxide ion, it is going to increase. So the negative charge is not at one position, it is delocalizing. ठीक है, so दो चीज तो हम यहाँ इसके बारे में कह ही सकते हैं. First thing is that regarding this we can say that unstable due to plus I, and we can talk about phenol that it is stable due to resonance. Now this is one of the main reason why phenol is going to be more acidic than alcohol. One more reason that we can discuss is the hybridization of the carbon atom that is directly connected with the OH bond. ठीक है, तो यहाँ पे ध्यान से देखिएगा. This carbon atom, it is sp3 hybridized, which is less electronegative. It is giving electron density to the oxygen atom. The carbon which is having OH in the phenol, it is what? It is sp2 hybridized. Now we know that sp2 hybridized atoms, they are having high electronegativity. So high electronegativity. Also, one more thing is that this oxygen atom, it will be showing resonance like this. This lone pair will go down and this will come here. So if the lone pair is going away from the oxygen atom, this oxygen atom will gain a positive charge. Now think about the hydrogen which is attached. Oxygen electronegative, which is going to get a positive charge because of resonance. So it is going to pull a lot more electron density, right? If I compare it with the sp3 carbon, and if I compare it with the alcohol case. So that is what happens. This OH bond, it becomes highly polar. Okay, this OH bond, it becomes again very highly polar, and one of the reason is the sp2 hybridized carbon atom, and then the resonance which is going the lone pair electrons which are going towards the benzene ring. So electron is flowing from the OH towards the benzene ring, and oxygen atom getting a positive charge. So this bond will be highly positive polar, and when it is highly polar, this hydrogen atom will have a highly delta positive charge, so it can easily leave out. Okay, it is already having a highly positive charge. यहाँ पे सबसे पहले आप लोग तो ये लिखिएगा. Number first point is phenol is more acidic than alcohol because phenoxide ion is resonance stabilized ठीक है. Now this is more important rather than the next line that I'm going to write regarding the alkoxide ion. Phenoxide ion is resonance stabilized, but alkoxide ion is unstable due to plus I effect of alkyl group, R group. ठीक है, तो one reason. Now see, if you write answer till resonance stabilized, phenoxide ion is resonance stabilized, you are going to get marks. Don't worry about it in the board examination at least. ठीक है. Next point is regarding the sp2 carbon atom and sp3 carbon. So last में also you will write also the OH bond in phenol is more polar due to sp2 carbon and resonance ठीक है. दिस ऑल्सो की बात तो बिल्कुल ही आपके लिखना जरूरी नहीं है, बट आई एम राइटिंग दिस, व्हाई आई एम राइटिंग दिस देन, बिकॉज समवेयर इन द ऑप्शंस ना आपको ये चीज मिल सकता है. लाइक इफ दे आस्क एमसीक्यू एंड एमसीक्यू में लिखा हुआ है phenol is more acidic due to following, and they have given listed reasons. Because phenoxide is more stable due to resonance. Next उन्होंने reason लिख दिया ऐसे, alkoxide ion is more stable because of plus I group. Third reason लिखा उन्होंने, alkyl ion is unstable due to plus I group. Third reason उन्होंने ये लिख दिया है कि the OH bond it is more polar in phenol. फिर ऑप्शन में दिया उन्होंने only one is correct, only two is correct, 1, 2 is correct, इस तरह से. So for those cases, I have written this down. If they give you Y type of question, why is phenol more acidic than alcohol? तो उसमें single line का आपको आंसर ये लिखना है. Due to because phenoxide ion is resin stabilized. That's it. उतने में मार्क्स मिल जाता है. ठीक है. मार्किंग स्कीम्स में इसके ज्यादा नहीं लिखा जाता. If you want to add further on, up to you. Don't worry on adding. ठीक है. चलिए. I hope you have written this down. Yes or no? Please tell me. Anyone still writing? Anyone still writing? No one is writing. ठीक है. चलिए ध्यान दीजिए जरा. एक सवाल आएगा आपके पास इस तरह से. This is basically how to distinguish between alcohol and phenol. So question will come something like this: A and B both contains OH group. ठीक है. And they're saying A turns blue litmus red, but B doesn't. ठीक है. और ऐसे लिखा रहेगा identify A and B. Identify A and B. So you don't have to be confused कि how will I know? Basically उन्होंने OH बोला है. That means it could be both of them are alcohol, both of them are phenol, or one is alcohol, one is phenol. The other statement that they are saying that A turns blue litmus red. That means A is acidic. ठीक है. And acidic कहाँ पे है? पानी के साथ acidic है. It's not like it's only acidic with active metal. A is acidic. ठीक है. That means A will be what? A is phenol. A is phenol. Okay, I hope you know that when you have litmus, then that is a solution, and you have to. I mean, in water, if something is acidic, then only litmus is going to work. Gas phase में नहीं काम करता. I hope you have seen this in 10th standard itself. The HCl gas, when it is evolved and you bring some litmus paper to it, it is not going to show any reaction unless you wet that particular litmus paper. So when you wet that litmus paper, then you bring it and HCl fumes are coming up. So HCl fumes, they may turn the blue litmus red. That is blue litmus. Huh? So A is phenol, and we will say that, and B is alcohol. That's it. You don't have to exactly say which alcohol. Okay. So next, we are going to look at the acidic strength of substituted phenols. I hope you have written this question down. We'll write the next topic. Acidic strength of substituted phenol. Now, what we have learned till here is it's all going to depend on the conjugate base. Conjugate base, it is having negative charge. So anything which increases the negative charge will decrease the acidic strength because it is going to destabilize the phenoxide ion. Anything which decreases the negative charge, it will increase the stability and it will increase the acidic strength. So basically, we have two different groups which can be attached on phenol. Those are going to be electron donating group. And these are basically the plus M groups. And when you add any electron donating group, it is going to lower the acidic strength. Examples could be CH3, or you have any alkoxide ion, OR, OCH3, OC2H5, and NH2. Okay, so all of these things are going to decrease the acidic strength. NH2 डाल दीजिए तो फिर basic हो जाएगा, but again, we're talking about acidic strength here. You will only get the case of CH3 and OR. Okay, और ज़्यादा आपके पास यहाँ पे कुछ case नहीं आता. Then we have electron withdrawing group. Electron withdrawing group. This is basically minus M. So this is going to decrease the negative charge, increase the acidic strength. Acidic strength. Now, one group that you are going to see is the NO2 group. Okay. You will have other things also, for example, aldehydes and ketones. They also are going to decrease the acidic. They are also going to decrease the negative charge. That is, they are minus M group. But basically, you are going to see NO2 in the questions. Now, another important thing that we have to keep in mind while we are talking about any Disubstituted benzene is the position of the second group. So see, our OH will be here. You don't have to compare where is the OH. OH से comparison की जरूरत नहीं है. But we have to understand that this is ortho position and this is your meta position and this is your para position. Okay. Now ortho position, if you remember, ortho is just like you don't have any carbon in between the groups. Okay. The groups are attached on adjacent carbons. That is ortho. ठीक है, अगर आपसे कुछ इस तरह से रहे ना, ऐसे करके दिया हुआ है, ठीक है, और यहाँ पे दो ग्रुप्स लगाए हुए हैं, so this is also ortho. ठीक है, अगर आपको ऐसे दिया हुआ है तो यहाँ पे ग्रुप्स लगाए हुए हैं, तो ये ऐसे मेटा नहीं हो जाएगा. दिस इज ऑल्सो गोइंग टू बी ऑर्थो. ठीक है, सो यू डोंट जस्ट मेमोराइज द पोजिशन, इट इज एक्चुअली रिलेटिव पोजिशन है ना, एब्सोल्यूट पोजिशंस की बात नहीं है. When we talk about ortho, meta and para, we don't talk about the absolute position, we are rather talking about the relative position. So ortho, 0 carbon atoms in between. So the adjacent carbon atoms are going to have groups. If you talk about meta, then you have to leave 1 carbon atom. So adjacent, 1 after the adjacent. Para is 2 after the adjacent. And that's not the thing that I'm trying to say here. When some group is attached on the ortho position, in the ortho position, what you need to check? First, you need to check plus M or minus M. ठीक है, first. ठीक है. Now, when you check plus M or minus M, and then once you get the answer, you don't have to check further on. But if there is some type of time, we will see this question. Then you need to check whether it is plus I or minus I. ठीक है. But first of all, look at plus M or minus M. If plus M or minus M is going to give you the answer, then you don't have to look further whether it is plus I or minus I. You don't have to look. If plus M or minus M is going to give you the answer. But in the meta position, you just need to check the plus I and minus I, because the mesomeric effect, it does not work on the meta position. So in meta position, check only plus I, the group is plus I, or is it minus I? That's it. Don't have to check anything else, because mesomeric effect, it does not work on the meta position. The third case is the para position. So in para position, again, the same thing as that of ortho, plus M or minus M first, and if and only if there is a tie, you need to check plus I or minus I. Okay. So your answer will be mostly from plus M or minus M. Anyone still writing?
Yes, sir.
Okay. Please write with me. Oh, sorry, not write with me. Write it down. Let me know once you're done. Waiting for Harsha and then. Let's see next one. There is a question which has been asked a few times. The question is something like this. Quite easy. Why orthonitrophenol is more acidic than orthomethoxyphenol. Okay. See, main hindrance that is going to be caused in these type of questions will be the structures. Okay. Until unless you know these structures, you will not be able to answer it confidently. You can answer, but not very confidently. So let us see the structures and then we will. See, without these structures you can answer it, but confidence नहीं आएगा आप लोग को, ठीक है? So we have OH and NO2. Here we have NO2. And here we have CS3. हाँ, आप लोग थोड़ा दिमाग लगा के बता सकते हैं? We have to look at the group, है ना? Nitro is in which group? Ortho, meta और para? Tell me guys. कौन सी group में nitro?
Ortho.
Ortho. What do we see in ortho? सबसे पहले क्या देखते हैं? प्लस m और माइनस m.
Yes, sir.
प्लस m माइनस m ना? तो NO2 बताइए, प्लस m है या माइनस m?
minus m.
हाँ, it is minus m ना? Nitro is minus m. ठीक है, अब इसके तरफ देख, अच्छा OCS3 होगा ना, माय बैड गाइस, OCS3 नहीं लिखा, मैं CS3 लिख दिया, तो ठीक कर लीजिए अगर आप लोगों ने कॉपी किया है. सो बी OCS3, O methoxy, ortho methoxy CH3. Now what about this OCS3? It is plus m or minus m. Again it is an ortho question, that is why we are first looking at the mesomeric effect rather than the inductive effect. जी बताएं.
Plus m.
Zaina, do you have idea about these things, plus m minus m?
I'm not sure, sir.
Yes, not sure. ठीक है, no problem. I will just.
We haven't done questions like these.
No, not about that. I mean, see how they are saying plus m or minus m is because of the 11th standard, by the way. So plus m and minus m, it is part of 11th standard. But I will tell you, it's very easy. You need to understand that this oxygen atom, will it have lone pair? Tell me.
Yes, sir.
Yes. So if benzene is attached with anything which has lone pair, okay, it is going to be plus m. Okay, anything. If benzene is directly attached with anything which has lone pair, directly attached to an atom which is having lone pair, it is going to be plus m. So for example, this is going to be plus m. Okay. Similarly, if you have benzene ring, I'm writing benzene as pH and there is NH2. So nitrogen is also going to have lone pair electron in this case. Okay. That is why it is also going to be plus m. Similarly, if you have pH and you have OH, maybe you have lone pairs. Okay. It is also going to be plus m. But if you look at nitro group, then it is pH and nitro is something like this, double bond O and a single bond with oxygen atom. So this nitrogen atom does not have any lone pair. One thing is that. The other thing is that, that's very important. Benzene directly connected to a atom which is having double bond or rather multiple bonds with more electronegativity. आपके पास आएगा benzene ring which is as phenyl ring. Then you have key atom. I call that anything that is directly attached to benzene ring, I call it key atom. So that key atom should have multiple bond with electronegative element. If you have a case like this, benzene ring connected to an atom which has multiple bond with electronegative element, that is going to be minus m. Can you read this phenomena, what I am trying to say? एक बार उसको बोलिए. Zaina, please read this, what I am saying here.
Benzene ring connected to an atom with multiple electronegative.
No. Okay, listen to me very carefully. Okay, this is something that you need to memorize. That is why it's very important. Benzene ring connected to key atom. Repeat.
Benzene ring connected to a key atom,
Which is further connected to an electronegative element via multiple bond. Can you repeat once again the complete thing?
A benzene ring connected to a key atom, which is further connected to an electronegative atom by multiple bonds.
Okay, very good. So let us suppose we have something like this. Okay, please keep your mic on. Phenol, which is connected to carbon, double bond O and hydrogen. Okay. So benzene ring. Okay. Benzene ring. Correct.
Benzene ring
Connected to key atom. What is the key atom here?
carbon.
Carbon is the key atom. So is carbon connected to any electronegative element via multiple bond?
Yes, sir.
And oxygen. So
Oxygen.
this is going to be minus M. Make sense?
Yes, sir.
Okay. So this is how we can identify minus M or plus M. So for plus M, benzene ring should be connected to E atom, which is having lone pair electrons. So there is no lone pair. Then look, by the way, there is one exception in the lone pair case, that is methyl. So methyl, the carbon atom, it does not have any lone pair electron, but it is still plus M because of hyperconjugation. That is another factor. But CST को as a exception आप अभी याद कर लीजिएगा. It has an explanation for sure, but it does not fits in the rule of lone pair. But again, we are going to look at this part. So minus M. So if it is minus M, that means it is going to stabilize phenoxide ion. Enough. Why does phenoxide it is stabilizing phenoxide ion as NO2 is electron withdrawing. This destabilizes phenoxide ion as OCH3 is electron donating group. So which will be more acidic? जो ज़्यादा stable वही ज़्यादा acidic. So this is going to be more acidic. ठीक है? When you copy this down, I'm going to give you a question in which you have to make structures, and after making the structures, you need to make the you need to decide which is going to be more acidic. है ना? उसको arrange करना होगा आप लोग को. I hope you have written this down. Question तो लिख लिया होगा आपने. Write another question. Arrange the following compounds in increasing order of their acidic strength. You need to make the structures first of all, है ना? Structures will give you an idea. Can you please send if you have drawn the structures at least? From Harsha. We'll take one more minute, guys, and then we will discuss the answer. Okay. First is propane one-all that you have drawn it correctly, Harsha. Second one is 2,4,6-trinitrophenol that is also correctly drawn. 3-nitrophenol is also correctly drawn. D1 is 3-toluene that is also correctly drawn. Phenol 4-methyl. So structures are fine. We will look at the order later on. Okay. Propane. Acha. Nice to see your bond lines. Zaina, nice to see the bond lines. It saves time, na? Zaina?
Yes, sir.
So it needs a bit of practice, but it will save a lot of time. Okay. 2,4,6-trinitro, very good. 3-nitro is also correct. 3,5-dinitro is also correct. 4-methylphenol is also correct. Okay. We have to discuss the acidic strength. Harsha, I have not got your answer. Sorry. Rishita, I have not got your answer till now. At least time is also up. So, propane one all. So propane one all will be something like 1 to 3 carbon atoms and OH. We will call this A. Then we have 2,4,6-trinitrophenol. So it will be benzene ring and OH. Nitro group on the second position, the fourth position, and the sixth position. So you have NO2, NO2, NO2. Trinitrophenol. So you have OH, phenol, and nitro in the third position, that is NO2Cl. Then we have 3,5-dinitrophenol. Here we are going to have OH. 3 and 5 both are going to have NO2. You can come closer. Now we have 2 more, phenol and 4-methyl phenol. So phenol will be just OH like this, and 4-methyl phenol will be OH and CH3 in the last, fourth position. Okay. Now we are going to, this is B, this is C, this is D, this is E, and this is F. So first one is the alcohol. I don't even have to discuss too much about it. Alcohol will have, all of these are phenols. So alcohol will have less acidic strength than phenol. So it is going to come at the end. Okay, so we are going to not consider it. If I look at the nitro groups here, then all the nitro groups are in the, this is ortho position, this is para position, this is ortho position. So all of these are nitro groups. It will be -M, and I will multiply this with 3 because there are 3 minus M groups. The NO2, which is in the C case, that is in the meta position, so it is not going to show any -M effect, rather it is only going to show -I effect. Similar is the case for D1. In the D, but we have 2 NO2 groups in the meta. This is also meta, this is also meta. So both of them are going to show -I effect, but there are 2. That's why I multiply with this. I will multiply this with 2. Phenol, I will say that it is 0. Now, if I look at CH3, it is going to be +M. Fine. So if I talk about the acidic strength, then first of all, the most acidic will be minus groups. So -M and -I, in this case, we have to consider -M. Okay? Because -M is what it is going to be stronger effect than -I. It is always stronger than -I. Okay? So -M, the largest -M we are having in the B structure. So B will be the most acidic. Now we have to look at -I. So we have C and D. In the D, we have 2 -I. So it will be D. And then we will have C. Now, generally students do one mistake that they keep +M after that. So it will be not +M. आप ऐसे चल रहे माइनस, उसके बाद 0 आएगा, उसके बाद ही प्लस आएगा. So 0 will be the phenol case when you don't have any groups attached. So after that you will have E, and after that you will have F, that is +M, and after that you are going to have A, which is alcohol. Alcohol will be always less than any type of phenol. Okay, please copy this down. Harsha, ये order था आपका? Yeah, very good. Okay. Let me know if you are still writing. Anyone still writing? Anyone still writing? No one is writing. Okay. Now this is all about the acid strength. You have, so by the way, if you get questions like this now, for example, compare the acidic strength of following. Okay. They have given 3 carbon atoms OH. Okay. And here you are having, let us suppose, chlorine. Okay. Versus you have 1, 2, 3 OH. Okay. और यहाँ पे आपके पास CH3. Now in both of these, if I say, let us suppose this is A and this is B. So in A we have a minus I group. No? Cl is minus I. So in the alcohol case also it is going to work. Here we are having minus I group, and here we are not having anything. We are only having plus N. Where is plus N? Right? We are having plus I group, that is the alkyl group. So chlorine here it is going to show some minus I effect. So that is why this will be more acidic. Okay. Another example, we have first हो गया. एक और example ले लीजिए. Let's suppose we have chlorine OH versus you have 1, 2, 3. You have कितने carbon? 1, 2, 3 carbon atoms. Keep 1, 2, 3 carbon atoms only. And here you are having OH. But in this case, the chlorine is attached on this carbon atom. Okay. So here also we are having minus I. Here also we are having minus I. But this chlorine in the B case, let's suppose this A and this is B, it is closer to the OH group. So it is going to show minus I effect more intensely. In this case, the B will be more acidic. Does this make sense? Yes or no, please tell me. हाँ जी बताएं. Second वाला समझ में आया सबको? Okay. So I am saying I group में है ना, I effect is distance dependent. Distance dependent. Okay. So strength of I, it is inversely proportional to distance. So in the A case, chlorine is very far away from the OH group. So when the hydrogen will leave, you will get an alkoxide ion, this negative charge. So this negative charge will be stabilized by chlorine because chlorine is minus I group. It is going to pull electron density. But in the B case also we are having chlorine. This chlorine is much closer to the oxygen, which is going to get the negative charge. So this chlorine in the B case will be much more effective in pulling the electron density from the oxygen atom because of the distance. Make sense? Yes or no, please tell me.
Yes, sir.
Okay. Let's suppose similarly you have this case in which you have OH. Here you are having chlorine versus you have OH, and here you are having fluorine. Okay. So we know that fluorine is going to be more electronegative than chlorine. So fluorine will have higher minus I effect. So minus I powerful कहाँ पे ज़्यादा है? It is more powerful in the, say this is A and this is B. So it is more powerful in the B case. That is why fluorine is going to, the one which is having fluorine, it is going to be more acidic. Okay. But you will not get this much type of questions in the alcohol. ज़्यादा सवाल आपके acidic strength में बनते हैं in carboxylic acid. There also we are going to see similar type of discussion. But please copy this down. You can write this part. I effect is strength dependent. Strength of I. Strength of I. Whether it is plus I or minus I, दोनों ही केस में it is inversely proportional to distance. जैसे जैसे distance बढ़ता जाएगा, the effect of I is going to decrease. Done, everyone? Anyone still writing? Anyone still writing? No, one is right. Let me write next. Now, acidic strength, we have discussed acidic strength. Next is reaction with carboxylic acid. Okay. Second reaction, the reaction with carboxylic acid. Please write with me. Alcohols react with carboxylic acid in the presence of concentrated H2SO4 or dry HCl to form ester. So the reaction is something like this. We are going to have carboxylic acid R C double bond O OH. Okay. Hydrogen of alcohol is used. Plus we are going to have HOR dash, that is alcohol. Yeah? So in this reaction, water is formed like this. So the OH from carboxylic acid, it leaves, and hydrogen from the alcohol, it leaves. It gives you R C double bond O as it is, bonded with OR dash of alcohol. So this fragment is coming from the carboxylic acid, and this fragment is coming from the alcohol, and we are getting water. I'll write some examples. आप लोग खुद से इसके आंसर बना लीजिएगा. ठीक है. So let us suppose we have 1, 2, 3 carbon atoms COOH plus CH3OH, है ना. सिंपल सा आपको एग्जांपल दे रहे हैं. CH3OH. इस केस में क्या होगा? You will 1, 2, 3 carbon atoms. You will have C double bond O wherever the carboxylic acid is. वहाँ पे CO कर दीजिए. And O, the CH3 group, है ना. That is from the alcohol. Plus water will be there, obviously. Second reaction दे रहे हैं, ये खुद से कीजिएगा आप लोग. So let's suppose you have 1, 2, 3, 4 carbon atoms and carboxylic acid like this. Plus you have let's suppose 2 carbon atoms alcohol. ठीक है. And all of these reactions are going to be in acidic medium. H plus यहाँ पे हम लिख देते हैं. This H plus will be from the concentrated H2SO4 or it will be from the dry HCl. Send the answer of the product that we are going to get here. Send the answer on my WhatsApp. Send the answer. The 4 carbon atoms, oxygen, and then the 2 carbon atoms. It's correct. Zaina and Rishita waiting for you guys. Rishita, you have not sent even the previous question. O missing है देखिए जरा. Zaina 1 2 3 4 carbon double bond and then O is missing. No, देखिए. Rishita, what happened? Are you sending Rishita? हाँ, Zaina. Makes sense.
Sir, I'll send this one.
Zaina,
Yes, sir.
you understood the mistake?
No, sir.
No. I'm talking about this oxygen atom. ऐसे एक oxygen atom होना चाहिए ना वहाँ पे भी? In your answer also?
Yes, sir.
You got the mistake now?
So, okay, yes, sir.
ठीक है, एक बार करेक्ट करके भेजिए क्या समझा आपने. आंसर तो हम बता ही देंगे आप लोग को, ठीक है, लेकिन इट इज बेटर इफ यू अंडरस्टैंड द मिस्टेक योरसेल्फ. You need to practice all of these reactions once the class is done. ठीक है, एक बार practice कर लीजिए, then organic chemistry is going to improve in this order only. If you are not revising things, then it will not improve. You will be always getting stuck in the drawings of product. वहां वैसे नहीं ऑक्सीजन वैसे तो ही ना आएगा. देखिए ऑक्सीजन किससे बॉन्डेड है, एग्जांपल जो हम लोगों ने कराया है ना, ऑक्सीजन इज डायरेक्टली बॉन्डेड टू which carbon atom? देखिए the carbon which is having double bond, that is only having oxygen, ना.
Yes, sir.
ठीक है, redraw कीजिए. You have to
That's why
redraw
the
it.
oxygen will also come with the key carbon atom.
Sorry, what?
This oxygen will also come. It will be attached to the key carbon atom.
Key carbon, वहां पे key carbon नहीं है ना, वो key carbon पहले था in the benzene ring. This carbonyl carbon, this is carbonyl carbon,
Yeah.
which is having CO. Okay, so this carbonyl carbon, see you have to do this. ये तो कराया है हमने, इस तरह से सोचिए तो जरा कम से कम. Try to think like this now. What is this R group here? What will be attached with oxygen? What will be attached with carbonyl? ठीक है, थोड़ा सोचिए. ठीक है, try to figure it yourself. Okay, fine, I'm giving you time. Try to figure it yourself. H5 1 2 3 हाँ ठीक है, fine. Rishita, yours is fine. Then you try to figure it out. Okay, I'm giving you a bit of time. ऐसे like you talk to yourself, carbon, and that carbon will have one oxygen, that is to for sure. Now the carbon will be having some alkyl group. The oxygen atom will be having some alkyl group. Okay, so try to talk to yourself and then understand it. And send the answer once you have drawn a new structure. Zaina, any update?
Yes, sir. One second.
ठीक है. आंसर नहीं आया आपका अभी तक. नहीं, ऐसे नहीं होगा ना जाना. ठीक है, एक सेकंड. देखिए यहाँ पे, मैंने प्लीज सर माइक ऑन जाए ना. ठीक है, ऐसे आप समझिए जरा. सबसे पहले ऐसे समझिए, C double bond O and O. This will be there, no? Make sense?
Yes, sir.
There will be R group attached here and there will be R group attached here. ऐसे ही तो है. Look at the general reaction that we have written. Make sense?
Yes, sir.
ठीक है. अच्छा, ये बताइएगा. This blue R will be coming from carboxylic acid or alcohol? The blue one.
Carboxylic acid.
And this red one will be coming from
Alcohol.
alcohol. Very good. ठीक है. अब ध्यान से सुनिए जरा. We have 1, 2, 3, 4 carbon atoms from in the carboxylic acid. Draw 1, 2, 3, 4 carbon atoms from carboxylic acid and the carbonyl carbon explicitly like this. Make sense?
Yes,
Till
sir.
here. Now this carbonyl carbon itself will be having oxygen, and there will be how many carbons are there in the alcohol? Tell me. How many carbons in the alcohol?
3. 2 carbon
How many?
atoms. And
2 carbon. 2 carbon atoms. No? So oxygen, 1 carbon, 2 carbon. Makes sense?
okay. Yes.
No, this is very similar to what we have done previously. No? Oxygen atom is having a bond always. Okay. Okay. Write a few remarks. By the way, let's suppose if you want to name this out. Okay, so the name for this Easter type of thing is like this. First of all, you have to identify the OR, that what is attached with oxygen atom. So this part, it will be known as oxygen, and here we are having 2 carbon atoms. So this will be known as ethoxy. Ethoxy. You have to identify the alkyl groups only. So this will be ethyl. Okay, this is ethyl. And then this whole thing will be known as 1, 2, 3, 4 carbon atoms. So prop, there is no double bond, carbon-carbon double bond. So AN, ester group is known as O8, propanoate. तो नाम हो जाएगा इसका ethyl propanoate. Ethyl propanoate.
So there are 4 carbon atoms.
Oh, my bad. Yes, thank you. 4 carbon atoms, it will be bute. Butane, ethyl butane. Okay, that will get. Write a few remarks regarding this reaction. The first remark is this reaction is AKA, also known as esterification. Why esterification? Because we are getting ester, and we are getting ester. Next point. the presence of bulky group on either alcohol or carboxylic acid reduces the rate of esterification. Okay, reduces the rate of esterification. So what we can talk about the rate of esterification? You can say for alcohol, the smaller, for example, methanol, it will be fastest, followed by 1 degree. Next will be 2 degree, and 3 degree will be very slow. Similarly, if I talk about carboxylic acid, for carboxylic acid, carboxylic acid, the lowest carboxylic acid कौन सा होता है? Lowest carboxylic acid is going to be HCOH. ठीक है? And there is nothing known as 1 degree carboxylic acid, 2 degree carboxylic acid. But थोड़ा सा आप समझ सकते हैं. For example, you have RCOOH. Rather, I should write it like this: CH2COOH, CH2COOH, which will be slower than R twice CHCOOH, and this will be even slower than R thrice carbon and CO. You can see that the number of alkyl groups are getting bulky. So bulky bas hona, that is more important. These orders you don't have to remember type of thing. रटना नहीं है इसमें. Last point we will write. Phenols show similar reaction with carboxylic acid. Phenols show similar reaction with carboxylic acid. So what type of reaction phenol will show? We'll have the carboxylic acid R, C double bond O and OH. Plus we will have phenol कुछ इस तरह से होगा. ठीक है? So what we will get? This OH and this H will come out as water, and we will have R, C double bond O, oxygen, and phenol. This. The phenyl will act as a group, and this will be acting as a, what we can say, alkanoate. ठीक है? यहाँ पे अगर मान लीजिए if you have one carbon atom, so ethanoate, 2 carbon atoms in this fragment, then 2 carbons to ethanoate, 3 carbons to propanoate, and phenyl. So phenyl alkanoate will be the general phenyl alkanoate. ठीक है? Depending on how many carbon atoms, you can change the alk part. Butanoate, propanoate, ethanoate, and so on. And if you don't tell here, yes or no, please tell me. हाँ, please, done. लिख लीजिए आराम से, लिखिए आराम से. Anyone still writing? Anyone still writing?